Good morning, everyone. Welcome to this latest edition of Power Hour. This is virtualization for OT. Our agenda today is we're going to do an introduction, we're going to go over some basics. Our friend George from WELOTEC is going to do virtualization in the substation. Our friend Pascal from Omicron is going to do some IEC 61850 basics and talk about virtualization in the power systems testing realm. I'll be showing you a hypervisor walkthrough, and then we'll open it up for questions and answers. We'll do something slightly different during our normal webinars. We'll be answering questions throughout, but we will just answer questions at the end. So feel free to ask questions as we go through, and we'll answer them at that point. George, would you like to say something about this slide?
Certainly. So, hello everybody. George Alagi from WELOTEC here. And growth in communications, networking, and compute technologies has led to greater advancements for protection, automation, and control system design. And this graph illustrates just how PAC design and PAC technologies have changed over the years. But it also showcases some of the possibilities for the future. But what I think it's important to point out, and what we will talk about today, is that with the load growth demand on our utilities, these advancements are not only a nice thing to have, but they're really necessary for the reliability and efficiency of the future grid. And today's OT professionals are the best, in the best position to ride this wave. Those who master virtualization now will shape how the grid runs for decades.
Thanks.
Certainly.
And Pascal, would you like to introduce yourself and speak to this slide?
Yes, so Pascal from Omicron. So my specialization is 62850 and digital substations. So hopefully that term, something you've heard before, digital substations, and I'll mention that quite a bit today for how that's enabling digital testing and virtualization. So this is a really good illustration right here of what we're talking about when we talk about a digital substation. Hopefully the top view is something that you're already somewhat familiar with, where you would have your primary equipment out in the yard, your circuit transformers, your breakers, things like that. And then you would have a control house that's actually dealing with the protection for those devices. So the biggest difference that you should notice here is the difference from the top to the bottom image is that in the top image, the conventional substation, it's all hardwired copper going back to the control house in secondary. But in the bottom image, we just have a single digital communication line. And so that might seem like a small change, but it actually enables a lot of new technologies, virtualization, and then hopefully you're already seeing some benefits there that the control house can get a lot smaller, especially once you start virtualizing that equipment. So we're going to see really here how that helps us out.
Just as an introduction to who we are, because we sent it out on LinkedIn, we are NovaTech Automation. We've been modernizing the grid since the 80s. We're a leading supplier of utility substation automation since the dawn of digitalization. We do have further down in the webinar support links, and if you want to find out more about us. We do empower essential industries and electric utilities to simplify complex power challenges. And we do that by offering a broad portfolio of substation automation with networking, metering. We do retrofit adapters for the D20 systems, Telvent, and we produce cabinets for you as well. Biotronics was among the first microprocessor substation IEDs to digitize power flow, so we consider ourselves on the forefront of digitizing substations. Orion makes the consolidation of data from all substation devices easier for operators, and we continue to add I/O, precision timing, and gigabit Ethernet to our other digital substation portfolio.
Okay, and I'll introduce WELOTEC. For nearly 60 years, WELOTEC has been a leader in producing industrial-grade computer and networking hardware for various automation applications. Initially focused on process automation space, or what we call today smart factory, our customers started to ask us to develop more and more products for additional industries, which includes the primary and secondary substation markets for power grids. For over a decade, we've been producing hardware specifically for electric utility applications and specifically for substations, as noted here on the slide. On the next slide, we'll show some examples of some of our products, particularly our substation automation, rugged substation automation products. These will be the products that we're referencing in today's webinar. But these are characterized by industrial temperature range, industrial temperature rated, even being passively cooled and fanless designs, which are key for situational awareness in substation. They still maintain their industrial temperature rating, even though they are fanless. But they're also IEC 61850-3 and IEEE 1613 certified. So again, designed and certified specifically for substation applications, and with plenty of features, things like hot swappable power supplies and storage drives with plenty of I/O for your typical deployment need, as you can see there with the server on the left. So that's WELOTEC in a nutshell.
Then Omicron, you can see it's been around since 1984, but a lot of what we're going to be talking about today is going to be actually IEC 61850 focus. So I'll highlight a little bit there that we've been working with IEC 61850 since 2001. So for us, it's not a new concept. That's what, bordering on 25 years now. So originally involved in a lot of the design of the standards, including 9-2LE, which pretty much everyone's using right now for their sample value streams. So fortunately, our new equipment looks much nicer than the the old school stuff. We have the CMC 500 out now for protection testing. And then on the next slide here, you can see some of the areas that we're involved in for testing in the power industry. You'll see it's a pretty wide range that really, if you utilize it in the power industry, then there's a very good chance that we're gonna have equipment to test it. Thank you, Ryan.
We are part of the vPAC Alliance, and we're encouraging all utilities to join the vPAC Alliance to help drive the open virtualized protection and control standards. Do you want to say something more to that, George?
I just mentioned that all three companies on this webinar today are members, as Ryan said, and we're really driving lots of innovation. It's a utility-led alliance. There's 10 utilities currently and about 25 vendor members, and certainly we're encouraging all the utilities to join so we could get their input on some of the things that we're presenting here and some of the ways that we're driving the industry.
So with Virtualization Basics, virtual is what the definition, I think it's from Webster dictionary that I got, was existing in essence or effect, though not in fact. We're going to focus on the effect that virtualization and virtual machines can bring. Virtualization is a technology that allows you to create virtual simulated environments from a single physical machine. The hypervisor is a software stack and OS that enables virtualization of machines. The virtual machine is a software-defined computer or server. The IEC 61850 is a set of standards defining substation communication. There are two types of hypervisors. A level 1, which is kind of called a bare metal hypervisor. Examples include ESXi, XenServer, KVM. And then we have the hosted type of hypervisor, level 2 hypervisors. And they are hypervisors that run on a software package on top of an operating system. Examples would be VirtualBox and VMware Workstation. The hypervisor's task is to provide hardware resources to virtual machines in the form of virtual device drivers. So it's kind of an extraction layer of CPU, memory, disk drives, network. And for that extrapolation, it presents back to the virtual machine. The virtual machine is an operating system that is given hardware resources by a hypervisor. Virtual machines can be installed on hypervisors using an image or with installation media, just like installing Windows or Linux on your laptop. The benefits of virtualization are resource partitioning, so that you can share out CPU and memory from the same hardware to different virtual machines. Isolation, so you can have a bunch of virtual machines on the same hardware that they can't talk to each other unless you allow them. And hardware independence means that you should be able to take these virtual machines and copy them onto different sorts of hardware. George.
Okay, I'll talk a little bit about virtualization in the substation, and I'll talk for a minute about the evolution of the substation and why the members of the vPAC Alliance envision this evolution to be critical for the energy transition, especially as it relates to ever-increasing demand, the ever-increasing demand on a power grid, the load growth demand, and incorporating alternative energy resources, from different, distributed energy resources. These virtualization becomes important to aggregate all the sources of generation. 50 years ago, substations were primarily electromechanical hardware systems before the introduction of the microprocessor-based equipment that Ryan mentioned from NovaTech. But the next advancement in substation automation came approximately 20 years ago with the first release of the IEC 61850 standard, which we mentioned here a couple times. Within the standard is a protocol that is a communication protocol that was designed to enhance the capabilities of the Ethernet that exists in the substation. Pascal will discuss IEC 61850 in a bit more detail in his portion of the webinar. But essentially, the standard provided interoperability among hardware devices. This means we can now bring substation functions and applications to standardized computing hardware and take advantage of the different type 1 and type 2 hypervisors that Ryan just discussed. So what we see today are certain components or substation functions, such as firewalls, gateways, RTUs, or protection relays, being moved to a standardized compute platform, but it is mostly type 1, what we're seeing today, where you have a single server running an application with its operating system specific to that function. However, with the power of modern servers that we're using, some of the examples that I showed here from WELOTEC, we'll be able to run multiple functions on the software-defined or virtualized platform, providing more flexibility and faster scalability compared to substations that require dedicated hardware for each function. Next, we'll talk about why now. Why now substations? Virtualization is not a new concept. It's something that has been used in a couple of industries that I'm many industries, a couple that I'm showcasing here, the data center and telecom industry. And what virtualization has done is, certainly provided higher efficiency with cost savings and faster scalability, and improving resilience for failover features to minimize downtime, especially in data center. In telecom, in addition to the cost savings and greater adaptability to changing demands, virtualizing the network functions helps with faster service provisioning for users in telecom. So being able to dynamically adjust resources to change traffic needs, and again, allowing seamless failover and recovery and easy integration with cloud platforms. So all of those benefits can be easily translated into the substations, and with substation applications becoming more powerful and allowing for more functionality, and the availability of servers and hardware that has been designed specifically for the harsh environments and applications of the substations, now we're able to bring virtualization that has been proven in other industries to the substation. So we'll talk a little bit about some of the benefits of bringing standard servers, and as I mentioned, Pascal will talk more about the communication protocol and the benefits of the IEC 61850-3 standard. But being able to have control, some of the options that are listed here for centralized control and monitoring, and if you're able to also remote in to the substation, in addition to all of these options mentioned here by using, standard compute hardware at the station level, you're also able to save lots of time and efficiency managing, updating, especially if there's remote communication or remote access into the servers. As the phrase is common, you don't have to roll a truck necessarily to then do what you have to do upgrades or look at your analytics or your diagnostics and things like that while supporting your virtualized applications. So next, we'll talk about kind of what the evolution is we're seeing today. Ryan mentioned the type 1 hypervisors, and that's what we see mostly today is what we're calling the conversion from conventional to digital substation. Not to be confused with digital twin, but actually digitizing the substation functions on standard compute hardware. You'll see that, the kind of gray section in the middle, it kind of denotes the type 1 hypervisor. We have a single application like a gateway or HMI or substation controller being run on a bare metal box with its OS. Specifically for that function, and that's primarily what we see today. However, we're only using a small portion of the actual compute hardware capability and performance. Maybe 10 or 15% when you're only running a single application on a server. So, some substations will have many servers to capture all the functions plus redundancy. So that's kind of what we're seeing today, and the next slide also kind of illustrates that. Each function with its own operating system and its own application running per computer. However, with virtualization, what you would see on the next slide is, as leading into the type 2 hypervisor that Ryan mentioned, where now you can run multiple applications, multiple operating systems on a single computer, which brings many benefits to the substation. Of course, even in the digital substation, the digital conversion we're seeing today, there's still plenty of benefits, without running multiple applications. You have one piece of hardware for training, for manageability, for being able to have flexibility with vendors. So there's still benefits now, but then as you go to the virtualized, there's even more benefits when it comes to lowering your CapEx and your OpEx. Of course, lowering the control room footprint that both Ryan and Pascal mentioned and highlighted, access cabling and all the things that Ryan showed in that one slide or a little earlier. So there's many benefits when it comes to centralizing and virtualizing the functions, along with being able to more easily upgrade and maintain the substation, and including if the substation has remote control access, remote access, then you can control and do even more things remotely. So that pretty much wraps it up for my portion of the webinar here, talking about virtualization in the substation. And this is just another example of how you would have all your different functions that could possibly be run on a virtualization layer or hypervisor on a single server or standard industrial hardware.
All right, so I'm going to do a quick overview of 61850, and then we'll talk about some virtualization opportunities in terms of testing inside the substation. 61850 is a huge topic, so I can only briefly touch on a couple aspects here, but hopefully it'll kind of give you a better idea. So this image here is illustrating kind of the timeline of what we've seen with substations, where all the way on the left is the very oldest architecture for a substation, where you have copper cabling going from your primary equipment to your relays in the control house, and then also your inter-device relay communications and even communications to the HMI being done with copper. And even at that point in time, you could have had some virtualized equipment, but it would really exist in the control center itself, but it would be somewhat unlikely. Then moving into more of a modern substation, you'll see that now we have less copper cabling. You kind of see in the very middle section there where it says IEC 61850. That's basically where Ethernet communications were replacing some of those copper cabling ties inside of the control house. So that offers even more opportunities there for virtualization, but still the virtual setups wouldn't be able to actually access all of the signals that we would like. So that's where the advent comes in all the way on the right-hand side here of a true digital substation, where any of your devices are actually able to see all of the data representing your entire power system. So here we can see that the primary equipment basically stayed the same, and what's changed is now the data from the primary equipment is digitized outside of the control house. So then by the time it gets to the control house, you can use just a single communication cable or redundant communications, and then any device can basically see any of that data. So that gives us a lot of new opportunities for different types of protection schemes, different types of testing, but then also kind of opens up opportunities for what do we actually need to see now from our relay setup inside of a control house. So now we're going to see why 61850 has actually enabled that. So with MMS, this is something that hopefully a few of you run into, but generally the easiest way to think about MMS is in its replacement of DMP3. So in my perspective, it basically does everything DMP3 has in the past, but has some nice new features. So for example, you can read out what an entire IED's data model looks like over the network, and then the files are in this open format where you can just import them into a testing tool and then utilize them that way. But this hasn't really been what has enabled the terms of like a digital substation. It's replacing communications we've used, but it's not really adding any new functionality in terms of digital substations. On the next slide here, we'll see what has really revolutionized the substation. So Goose and sampled values are two protocols as well. So MMS is a protocol inside 61850. Goose and sample values are two other protocols inside of 61850. The difference here is that Goose and sample values were created to be incredibly low latency so that you could replace actual hardwired communications in between relays. So you could replace cabling for things like trip signals, signals to open and close breakers, and then also digitize your analog values. So if we're talking about analog, it's sample values. If you're talking about binary control replacement, it would be Goose. And so these signals can do those functions in basically the same amount of time that traditional copper hardwiring could do. So this opens up a lot of new avenues for testing. One of the big ones is that it can be a lot safer because now if you want to isolate a device for testing, you don't actually need to isolate it from potential. You just need to logically isolate it on the network. And we'll take a look at what that actually looks like. But then also your automated testing for SCADA, you can actually see all of your protection signals right along with your normal control signals that you would have been able to test. Also remote testing, now you can inject from a virtualized piece of equipment living on the substation network instead of having to physically inject. You can simulate entire devices completely in a digital form, and then you can monitor even the ancillary signals that in the past you weren't able to monitor. So for example, with now with 62850, we're actually sending our time synchronization signals on the network via PTP instead of using a hardwired coax cable. So now you can actually monitor that data as well directly from the network. And so this is really what's changing our view of what a substation is and creating the idea of a digital substation. So on the next slide here, we'll take a look at the virtualization. So like, what does this actually look like for virtualization? We see that 61850 is what has enabled us, but now what's the implementation? And this is not theoretical. This is actually what's out there in the world working in real substations. So this would be a normal design where you have a station bus and a process bus. For those of you that are familiar with older substations, the station bus would have been the Ethernet network you would have already been interacting with. And then what's changed with the digital substation is this addition of the process bus that actually is replacing your hardwired communications. So this is normally where your things like your analog sample value streams would live, and then some goose messages as well. So the why this is important is because this should give you an idea of if you have a virtualized piece of equipment, where does it need to live in your substation? So with a virtualized equipment, it's going to, instead of looking at those hardwired copper signals, it's going to need to look at signals on the network. And so for virtualized equipment, you can, for example, take the Bay controller and those protection IDs and make them live on a server as a virtual device, and then connect that server onto the process bus and station bus, and now it has access to all the signals that a traditional relay would have in a conventional system. You want to jump to the next slide here? So where I see a lot of hurdles being represented for customers at this point with the idea of digital substations, but then especially with virtualization, is they're always asking, okay, then how do we test it? So people are very familiar with the idea of what you see on the left, where essentially to test your relay, you would have to isolate it from any potential energy, and so you would use test switches to do that. And then you would bring in a test set and you would inject current and voltage. And that's what we've been doing for a very long time. But now we have new opportunities to do this in a different way. So you're still going to need to test your power system. That's not going away. But when you're actually doing your testing, instead of needing to open physical test switches, which have the potential to create safety issues, now you would be logically isolating your devices from the potential, which is a digital potential now. And then for your testing tools, you can either have a physical piece of equipment that's looking at the signals on the network that's doing the exact same job that the traditional protection equipment would have done with injection and monitoring. But now you can even do that with completely virtual testing tools, because the virtual testing tool has access to all of your protection signals, but then at the same time even has all of your SCADA signals. So you can do a lot of interesting testing that way. You want to jump to the next one? Yeah. So in terms of what that looks like in realistic scenarios, we have a few different products that really benefit from this. One of them is Relay Sim Test. That is actually a modeling-based protection approach, protection testing approach. So why this is something that's enabled from digital communications is because with a traditional injection test set, you have to go to each place where you want to inject, and they can be physically separated by large distances. So you might need multiple pieces of test equipment, and then you might need to synchronize all of those. And it's definitely possible to do, but it's an undertaking. Where with a either virtual or a digital-based approach, you can actually inject all of your protection signals onto your network so that all of your IEDs see it simultaneously. So instead of just needing to inject current to look at one overcurrent on one relay, you can actually test your entire protection scheme and with a realistic scenario. Like, what does it look like when a tree would fall on this line, rather than is my overcurrent on this certain IED operating correctly? And so with the advent of digital signals, that is significantly easier to perform. But then we have now virtual versions as well of Station Scout, which is kind of a SCADA monitoring and IED communications monitoring tool, and Station Guard, which is an intrusion detection system. So with both of those, we have virtual versions now because they only need to look at the data that exists on the network. So with a virtual server, or with a server that can host virtual equipment, then you can place that directly onto the network and monitor those signals. So we get a lot of benefits from this, but people shouldn't really be scared about like the idea that, okay, now all of this is going to be different from our protection. We need to retrain everything. From the actual protection workflow, it actually ends up being somewhat similar. You're still testing a protection scheme. It's just really how you're interacting with the data has changed. So from the perspective of testing tools, they don't really care if it's virtual, if it's hardware, if it's centralized. It's all just signals on a network. And so realistically, you don't need to do a lot of retraining to test in a virtual environment versus a traditional conventional environment. So then here is an example as well that hopefully gets your gears turning a little bit about what might be possible in the future. So this is an actual system setup that we've implemented, where you can see that we had a server that was running virtual relays through a hypervisor, a virtual RTU, and then even a virtual version of our testing tool, Station Scout. So with that, this is a system that you could use in a lab environment, but it's also theoretically the exact system that you would deploy in the field. And so in a lab, you can add in the virtualized testing tool here, but then just hook up an additional external switch, utilize additional testing tools. For example, we were using our modeling-based tool to then test the protection on those virtual relays, and had an external lab-based PTP clock. So where this could be really powerful in the future is now with a virtualized environment, virtualized relays, you can actually simulate your entire power system in the lab, take your entire server out into the field and deploy it, and you've basically already tested everything. Sure, you're still going to have to recommission or do your final commissioning, but it's much better to find any problems early on in the design phase rather than once you're out in the field and it's very difficult to fix. So this I can see as being the real benefit here in terms of testing, is once you have virtual IEDs, you can actually test your exact system before deployment. But then also you can redeploy and copy and paste very, very easily. So there's a lot of nice, very nice features that are going to come with virtualization, and all of that virtualization is really enabled by our digitization. So we need those digital protection signals to really enable a lot of this cool technology. Thank you.
Thank you, Pascal. NovaTech has a product announcement. The VX will now run on Proxmox hypervisor. It will be available at the end of Q3, so end of September this year. It's not available for purchase right now, but you can contact sales for a 90-day evaluation. The reason I mention this now is because for the live demo, we are going to be demonstrating just a very basic what a hypervisor looks like. So this is the Proxmox hypervisor. We can see here there's a data center. You can have clusters of Proxmox hypervisors together. This is showing the actual hypervisor. You can look down here and find out all the things available about the hardware it's running on itself. This is a virtual machine, Orion VX. You can look at the extrapolated hardware and be able to change these various memory processors BIOS, generally on the fly. If you expand memory, there's things for ballooning or non-ballooning. Proxmox term for whether a few virtual machines can share the same RAM or whether it's dedicated to a virtual machine. You can share the CPU cores as well as the disks that are on the underlying hypervisor. Basically segment them out, virtualize them, and give them as a solid disk to the virtual machines. Well, this one's turned off, but we've got 1, 2, 3, 4, 5, 6, 6 virtual machines running, all doing the same thing on WELOTEC hardware. So it's a couple of VXs, firewall, Omicron Station Scout. We've got a syslog server, an SMP server, and Argus, which will be released soon as well. Now commences the Q&A portion of the webinar. So I haven't seen any questions about this, but if you have any questions, feel free to put them in the chat so that we can answer them. All right. Apparently we did a great job explaining all the content. So if you do have any questions about the webinar, feel free to contact us for more info. We'll end the webinar there with a few things for the community sites. So this is the NovaTech automation community. Feel free to join for all the things that you see here, the compliance, drawings, user manuals, tech notes, all of the like.
Yeah, and I encourage you to check out the WELOTEC knowledge page. We have several case studies, white papers, and various things there. And of course, feel free to reach out anytime for questions, and we'll be happy to support you.
Yeah, and of course, the same from the Omicron side, especially anything 621.850 based, you're going to be running to that very quickly once you're entering a virtualization, and you don't want to plan on how do we test this only after you've implemented it. So definitely, I can recommend getting educated early and getting familiar with testing tools. But the other thing I just wanted to mention here is you saw that on the last slide that I presented about the setup that we had for virtual relays. It's something that it's very simplistic for you to set up in your own lab environment, and I would recommend getting ahead of the virtualization as early as possible. Get your lab set up, get a server, run some relays, and actually see how this is going to function in the future. But I think you'll be pleasantly surprised that it in terms of your already existing knowledge base, you'll be able to utilize it quite well with the virtual setups.
Thank you for the call to action there, Pascal. Definitely agree with getting virtualization into your labs right now. And one of the best ways to do that is to join the vPAC Alliance, as mentioned previously. Like join the like-minded vendors and utilities that want to drive the change for virtualization in the substation. This is our sales engineer booking page. Feel free to book with a sales engineer if you want to talk about virtualization options for your RCUs or talk about any of our products that you saw. And that concludes the webinar. So thank you all very much for attending. We sure appreciate your time and being able to present to you.
Yes, thank you.
Yeah, thank you very much.